Here I'm going to look over some vital pieces of information we can get from the factored form of a quadratic. Let's start off by finding the x-intercepts, which are also known as the zeros or the roots of a quadratic. This quadratic is written in factored form, so the multiplication of these two brackets, and that makes it somewhat easy to find these x-intercepts. But more importantly, you should understand how to find the x-intercepts for more complicated equations. So anytime you're finding an x-intercept, keep in mind you're finding points on the graph where the y value is 0. So you want to have that in mind, especially as you get into more advanced math, that this is the most important part, that to find an x-intercept, you are going to make the y into a 0. You're finding points on the graph where the y value is 0. So I'll put a 0 here on the left side. I have 0 is equal to the product of these two terms. And now let's think about the logic behind the next step. If you have two brackets that multiply to 0, you're basically looking for two numbers that multiply to 0. When you are told that there are two numbers out there that multiply to 0, you would think to yourself that maybe the first bracket has a value of 0 and the second one could be any number, which I'm going to use as a hashtag. Or maybe it's the other way. Maybe the first bracket is just any number out there, but the second bracket is a value of 0. These are the only two ways to get two numbers to multiply to 0. That's why the next step I'm going to show x plus 1 is equal to 0 or x minus 9 is equal to 0. A lot of students, especially the weaker ones, they prefer to skip this step. And although in lower levels of math, you will get away with it, as you get into more and more complicated math, this step will mean more. So please don't skip this step. Show it. You can thank me later on when you get into more complicated math. But for now, let's go with that. Let's say you knew or that you should show this step. You can isolate x and you get x is equal to -1. I know, some of you would have said, I knew that already from this bracket. But again, in more advanced math, you're gonna benefit from showing these additional steps. You're also less likely to forget. So next, x minus 9 equals 0. We have 0 plus 9, and we get x is equal to 9. So there you have it. These are your two x-intercepts. On a graph, here is what we have found. We found the points where the y value is 0. So we've got -1, 0, and we've got 9 and 0 right there. Okay, so these are the x-intercepts, -1 and 9. They could also be written as points. X-intercept points would be -1 with a y value of 0 and 9 with a y value of 0. So these are two vital points on this graph. Next, we're going to find the axis of symmetry. So AOS. The axis of symmetry is the x value of your vertex, which will be your optimal point, a max or a minimum. The axis of symmetry is the average of your x-intercept points. Keep that in mind. Remember it that way. It's the average of the two x-intercepts. So it's going to be -1 plus 9 divided by 2. And that gives us an axis of symmetry of x is equal to 4. You will lose marks on a test if you say the axis of symmetry is 4. Don't do that. Make sure you say x is equal to 4. Okay, so I can go here at 4. That means this is the symmetry point on this quadratic, on this graph of this parabola. And I just need to know what's the y value for the vertex. So to get to the vertex, we take the x value of 4, plug it into the equation. So we have 4 plus 1 times 4 minus 9 gives you a y value of -25. And that tells you your vertex is the point for -25. Okay, so I'll do that. Let's say -25 is somewhere down here. And there's our parabola. So factored form can quickly help you find the x-intercepts, and the average of your x-intercepts is your axis of symmetry. You plug in x equals 4 into the equation to get the y value of the vertex, which will be at -25. And there you have it. Let's now do another example. I would recommend, if you understood this example, I would recommend you pause the video, try it on your own, and then play it, see if you get it right. Pause, try on your own, and then play. Okay, so assuming you're a dedicated student, you've done that, you tried it on your own. Let's see if you got the x-intercepts correctly. X-intercepts are where y is 0. So I put the 0 right there. 0 is equal to -6 times x minus 2 times x minus 8. This time we have a product of 3 different terms that multiplies to 0. -6 is not a 0, so that means one of these two has to have an answer of 0. Right? That's the only way. Think about it. I tell you -6 times something equals 0. There has to be a 0 answer here or a 0 answer in this last bracket. That's the only way the 3 will multiply to a 0. So that's the reason we say x minus 2 equals 0 or x minus 8 is equal to 0. Rearrange, you get x is equal to 2. Rearrange, x is equal to 8. I'm aware from my experience, the weaker students don't want to show any of this work. They prefer to just say 2 and 8, just by looking at the equation. And again, that might work for lower levels of high school math, but as you get into more complicated math, trust me, you're going to want to show these crucial steps. In fact, the more steps you show, the more you will remember. So here they are. These are your x-intercepts. X is equal to 2 and x is equal to 8. Let's now do the axis of symmetry, which again is the x value of the vertex and happens to be the average of your x-intercepts. I add the two x's, divide by 2 to get their average, and I get an average value of 5. Let's show on a graph what we have found so far. First x-intercept is 2. Second x-intercept is 8. Axis of symmetry is that x is equal to 5. Now I can use the 5 to find the y value of the vertex. So I plug in 5 for x, and then I solve. -6, that's a 3, that's a -3, and that's an answer of 54. Okay, so I go to 5, and let's say 54 is up here. And there we go. There's your quadratic. This time it opens down. We're not surprised because of this negative on the 6. That makes it open downwards.